I'm audible. Okay, means I'm audible to everyone. No issue. So in last session we have understood what is Mealy machine, what is Murray machine. We have also converted Mealy machine to Murray machine and Murray machine to Mealy machine. Correct? Yes or no?
Yes, sir.
Okay. So today we have to understand the minimization of finite automata. So we will see it one by one. Just wait a minute. So slide is visible to everyone. Presently, only the statement is visible to all of you. That is the construct a minimum state automata equivalent to the finite automata. Describe.
Hello, sir.
Yes, describe within this table.
Please start recording.
Yes, yes. Okay. So either table is given or a diagram is provided within the problem statement. So if diagram is given provided, then you have to prepare the table first, like this, that number of state and its transition for input 0 and input 1. Or as per the inputs, you have to prepare the table. Clear? So here table is provided and you have to prepare the minimum state automaton. Minimum state automaton, this automaton means it is a finite automata. Okay, it is a finite automata. So you have to prepare the minimum state finite automata. Means if possible with the technique you have to reduce this 7 state to the less than 7. 7 states are provided here. So you have to prepare it into a less than 7. So whatever is the thing you are going to consider means it may be a 6, 5, 4, 3, 2, 1 like this. But it should be less than or sometimes it is equals to means it is not going to reduce means you are going to obtain the same number of state. But it is rare case. Either it is going to reduce at least one state minimum, 5 state minimum, okay, like this. So how to reduce the number of state that we have to observe. Now why there is a need to reduce the number of state? Due to the hardware or software limitation, means when we are preparing any machine, machine means as I told you that machine means not always a hardware or a actual hardware functioning device. So it is an abstract computing device. So abstract computing device can be anything. It can be a software tool, it can be a hardware tool. So before actual preparing or we can say manufacturing of that machine, we have to check the feasibility that this number of states are good for the execution. It requires much time or less time. So accordingly, we have to set the number of state. So for that purpose, if we have prepared the more states here, we can minimize them. So how to minimize them? So these are the states. As we know that arrowhead indicates the initial state and circle is going to indicate the final state. Circle to a particular state, it is going to indicate a final state. So we have to prepare the sets and that sets are labeled with the pi. Pi 0 is the initial set and how it is prepared that I will tell you. That set is partitioned into a two subset. It is a set of final states. Here it is Q2. Final state is only one. Q2 is here and set of non-final state. So remaining all states are here Q0, Q1, Q3, Q4, Q5, Q6, Q7. Okay. How to prepare the pi 0? Set of final and non-final states. Is a final states and it's a non-final states. Okay. Next pi 0. After pi 0 we have to obtain the pi 1. In some references it is for your understanding, that is final and non-final. These are actually 0 equivalent. So what is equivalency, that we have to check. These are 0 equivalent, these are 1 equivalent, that we have to check now how they are equivalent. So to find out the equivalency, we have to check that which state is equivalent with the another state. Means we have to partition this set. There are two sets, set number 1 and set number 2. So this set number 1 we cannot partition it because it is going to contain only one element. But we can partition this set with the basis of equivalency. So how to check that equivalency, that I will explain you now. So we have to first check the equivalency in such a way that Q0 is equivalent with Q1, Q0 is equivalent with Q3, Q0 is equivalent with Q4, Q0 is equivalent with Q5, Q0 is equivalent with Q6, Q0 is equivalent with Q7 or not. So how to check that? That I will tell you here now. Q0, first we will check with the Q1. Do not check the Q0 equivalence with the Q2. No need to check because they are already separated. They are already within the different set. So Q0 equivalence with the Q1, that we have to check. So just observe this table and accordingly we have to see. So Q0 with input 0. What is the transition? Q1. Write down Q1 here. Q0 with input 1. What is the transition? Q5. Next Q1 with input 0. Q6. Q1 with input 1. Q2. So we have to check that these two states, Q1 is Q1 and Q6 are within the same set or not. So 1 and 6 within the one set, 1 and then Q5 and Q2. Q5 is here and Q2 is in the different set. So these are not equivalent. Again, I am explaining you how these are equivalent and how not equivalent. So please listen carefully. Just write down the transitions of Q0 and Q1 for input 0 and 1 from the given table. No need to do any calculation. This transition we have to write down Q1, Q6. This transition I am going to write down Q1, Q6, Q5, Q2, Q5, Q2. Now what I have to check, that Q1, Q6, these two states. Okay, just wait a minute. I just erase this thing now. Now Q1 and Q6. Q1 is this set and Q6 is also within the same set. Okay, so we have to check for the next Q5 and Q2. So Q5 is in the set, but Q2, if you observe, it is within the another set. Okay, so for both input transition, means for input 0 also and for input 1 also, whatever is the transition, both transition must be within the same set. That is the condition of the equivalency. Q1 and Q6 within the one set, but Q2 and Q5, these are not within the one set. So they are not equivalent. Q0 and Q1 are not equivalent. So which state is equivalent with the Q0? That we have to check one by one. So Q0 equivalency we have to check now with the Q3. Okay. So we have to just write down the transitions again for input 0 and 1. Okay. So what is the transition for Q3? This one is the transition. So Q1 and Q5 as it is, and this is the transition for Q3, Q2 and Q6. So here it is Q2 and Q6. Now we have to check this thing. Q1 and Q2 is within the one set? No. Q1 is here, Q2 is here. They are within the different set. No need to check the next. So they are not equivalent. Next 0 and 1 again. Next again we have to check for the Q0 and Q4. Sorry. So Q0, what is the transition? Q1 and Q5. Q4 transition 7 and 5. Q7 and Q5. So 1 and 7. Q1 and Q7. Q1 is here, Q7 is here within the one set. So no problem. Q5, Q5 within one set. So they are equivalent. Q0 and Q4 is equivalent. So here we write down Q2 as it is because we cannot bifurcate this set. Only one element is there. So Q0 is now equivalent with what? Q4. Next we have to check 5, 6, 7 we have to check now. But it is up till now it is only equivalent with the Q4. Only it is equivalent with the Q4. So we just remove all this thing now and we have to check the equivalence with the 5, 6 and 7. Clear? So if you are facing any difficulty in the understanding, then please let me know. If you face any problem at any stage, then please on your mic. What is the transition of Q0, Q1 and Q5? Next, what is the transition of Q5, Q2 and Q6? So Q1 and Q2. So these are within the one set? Yes or no? Students, can you please reply?
No, sir.
No. Q5 and Q6?
Yes, sir.
So these are equivalent or not? Q0 and Q5 equivalent or not?
Not equivalent.
Not equivalent because this Q1 and Q2 are within the different set. Both should be within the one set. These are within the one set, but these are not within the one set. Okay. Next, Q0 with Q6 we have to check. 0, 1. So Q1, Q5, Q6, Q6, Q4. So 1 and 6. 1 and 6 within one set. 5 and 4. 5 and 4 within one set. So they are equivalent. This Q0 and Q6 are equivalent. So after Q4 we have to write down Q6. Next, last we have to check for the Q7. So let's check for the Q7 now. So 0, Q0, Q7, 0 and 1. So Q1, Q5, Q7, Q6, Q2. So Q1 and Q6 within one set, Q1 and Q6, but Q5 and Q2. Q5 is here, Q2 is here, so they are not equivalent. So only two states are equivalent with the Q0, that is Q4 and Q6. So we will write down as it is. So remaining states, how many states are remaining? That we will see now. So 1 is remaining, 3 is remaining, 5 is remaining, and 7 is remaining. Okay, so equivalency of 1 is check with 3, then check with 5, and check with 7. In this way, we have to proceed. That Q0 equivalency is checked. If Q0 is equivalent with Q1, then we have to check the Q3 equivalency with Q5 and Q7. Understood? So here we have to prepare the equivalency set of Q1 with the Q3, Q5, Q7. We have to check that first, that whether it is equivalent with all or with one or two. So can anyone tell me that Q1 is equivalent with which state among these Q3, Q5 and Q7? Any one of you, can you please tell me? Q1 is equivalent with Q3 or Q5 or Q7. We have to check for all these three. Q1 के ट्रांजिशन फॉर्म मेंशन किए मैंने, Q0 के ट्रांजिशन लिख दिए थे। Q1 के ट्रांजिशन ये है Q6 और Q2, Q6 और Q2. Okay, now let's check the transition of Q1 with the Q3, that Q1 is equivalent with Q3 or not. Okay, so let's see Q1, Q6 and Q2, Q6 and Q2 within the one set, Q6 and Q2 not within the one set, so no need to check for the input one transition, means this Q1 is not equivalent with the Q3. Now Q1 is equivalent with the Q5, Q6 and Q2 within the different set, so no need to check further, so it is not equivalent with the Q5. Then Q1 with Q7, Q6, Q6 within one set because only one state is there. Q2 is also, Q2 is here, so within the one set. So Q1 and Q7 are equivalent. Q1 and Q7 are equivalent. Understood? So now remaining states are only two, that is 3 and 5. How many states are remaining now? Only 3 and 5. So we have to check the equivalence of Q3 with the Q5. So let's see now whether they are equivalent or not. We have to write down them here. Suppose I write down Q3. If that is they are not equivalent, we have to prepare the separate set of Q3 and Q5. That is the thing. If any state is not equivalent with the any another state, then we have to prepare a separate set for that state. Clear? So we will check the equivalence of Q3 with the Q5. So 0, 1. So what is the transition of Q3 and Q5? Same transition. If you observe, the Q3 and Q5 having the same transition. I just highlight them here. Just wait a minute. If you observe the transition of Q3 and Q5 same Q to Q6. Q to Q6. Understood? So when same transitions are there, most probably they are equivalent. Q2, Q2 within the one set, Q6, Q6 within the one set. So here I am going to write down Q3, comma Q5. And here I close the set. Okay? So in this way I am going to prepare the pi1 set. That is the one equivalent. One equivalent means these states are equivalent to each other at the first level. That is the one equivalent. Now we have to find out the next. That is a pi2. So next pi2 we have to find out. In pi2 again we have to check that these states are still equivalent with each other or not. And when we have to observe the pi2, we have to look into the pi1. And when we have to prepare the pi1, we have to look into the pi0. Means how we have to look into that. Observe that we have to check the Q0 equivalence with Q4 and Q6 only now, because Q0 is grouped together here with the Q4 and Q6. So now we have to check the equivalence of Q0 with the Q4 and Q6 only. With remaining state, no need to check because already it is checked within the pi1. Okay. So what is the transition for the Q0? That is Q1 and Q5. What is the transition for the 4? That is 7 and 5. And for 6, 6 and 4. So now when you are preparing the pi1, you are observing the sets within the pi0. Now you are preparing the pi2 set, so you have to observe the pi1 set. Clear? So just observe that Q1 and Q7 within the one set, Q1 and Q7 within the one set, yes. Q5, Q5 within the one set, yes. So here it is the Q5 within the set of Q3. So Q0 and Q4 are still equivalent. Now we have to check the Q0 equivalence with the Q6. So Q1 and Q6 within the one set, Q1 is here, Q6 is here. So they are not equivalent. Q0 and Q6 is not equivalent. Why they are not equivalent? Please try to understand that Q1 and Q6 are not within the one set. When we have to prepare the pi2, we have to observe within the pi1. Understood? If you have not understood, then please ask me. Then Q6 we have to write down here separately. No need to check its equivalence with the other state. Directly you have to write down. Okay. Now we have to check the equivalence of Q1 with the Q7. That still they are equivalent or not. So just remove this thing. Q1 equivalent with Q7. Only we have to check the equivalence of Q1 with the Q7, not with the other state. So what is the transition of Q1, Q6 and Q2? And what is the transition of Q7, Q6 and Q2? Same transition. So no need to check actually when you have the same transition. Q6, Q6 within the one set, Q2, Q2 within the one set. So they are still equivalent. When you have the same transition, most probably they are equivalent. And Q3 and Q5 also having the same transitions. So Q3 and Q5 are still equivalent. So just remove this. And we have to continue with the preparation of next set. Still we have the same number of sets as like previous. Means if we obtain the same set here within the pi3, like here within the pi2, then we have to stop. Now we have to check that Q0 is still equivalent with the Q4. So let's check the transition. And as we have to prepare the pi3, we have to look into the pi2. Q0 is equivalent with Q4 or not. What is the transition of Q0, Q1, Q5? What is the transition of Q4, Q7, and Q5? So 1 and 7 within the one set still yes. And 5, 5 within the one set, so still they are equivalent. So Q0, Q4, Q6 as it is, then Q1, Q7 because both having the same transition. Number of sets Q2, Q2. I just change the color here. Q0, Q4, Q0, Q4 is here. Q6 is here, Q6 is here. Q1, Q7, Q1, Q7. Q3, Q5, Q3, Q5. So we can say that pi 3 is equals to pi 2. And when we obtain this situation, that same sets we are going to repeat. At that time we have to stop. Okay, and when we stop here, we have to observe the number of sets, that how many sets we have prepared. So how many sets we have prepared here? 1, 2, 3, 4, 5. So these 5 sets are nothing but the 5 states, and obviously these are less than 7. So in this way we are able to minimize our finite automata. In this way we have prepared a minimized finite automata or minimum state automaton equivalent to the finite automaton which is described by this table. Understood? Now we have to prepare the table using these states, that is this combination, with the help of this combination. So how to prepare that table, that I will tell you. Just wait a minute, we have to write down these states now. So if you have any doubt within this, then please tell me. Have you understood this? Yes or no?
Yes, sir.
Yes, sir.
So just try to remember the states. 0 is equivalent with 4, 1 with 7, 3 with 5. Because we have to carry forward then here. That what we prepared the pi 3. Q2, Q0 is equivalent with Q4, Q6, 1, 7, 3, 5. So I just paste the table also. So it is easy to write down the condition. So I'm just going to repeat that pi 3 here. We are able to prepare the minimum state finite automata Q2. This table is for reference. I have pasted this table for the reference means to write down the transitions for the minimum state finite automata. We have to obtain the transitions for the Q2, Q0, like that. So now I'm going to prepare the conditions like this. State, input, zero. So just try to start from the initial state Q0 is the from the ascending order we can say, but write down in the combination. Whatever is the combination is there. Q0, Q4, then Q2, then Q3, Q5, Q4 is your 5 is 6. Okay, Q1, Q7 is remaining again. Q1, Q7, Q2, Q3, and then what? 0, 1, 2, 3, 4, 6 is remaining. So here we have to just write down the transitions. Nothing else. So Q0, Q4. So Q0 and Q4. This transition we have to write down here. So what is it here? Q1, Q7. So it is Q1, Q7. Next, 0 and 4 for input 1. 5, 5. Okay. What is that? 5. So do not write down only 5. Try to write down Q3, Q5. Okay. Because we have the combination. Q5 separate state we don't have now. It is combined with the Q3, Q5. It is one group now. Okay. 1, 7, Q1, 7. So Q1, approximately Q1 and 7. Q6, Q2. So it is only Q6. Here only Q2. Because Q6 and Q2 are separately provided here. Next Q2. For Q2, what is the transition? Q0 and Q2. So Q0 is not appearing as a single state. Here we have done Q0, Q4. And here is Q2. So Q2 as it is. Next Q3, Q5. Q3, Q5. Q3, Q5. Q2, Q6. Q6. Next Q6, Q6 and Q4. Q6 and Q4 is with Q0. Q0, Q4. In this way, we have to prepare this finite or we can say minimum state automata. Understood? Here we can write down its tuple, that is M. Q summation, then del. Del is already mentioned here. Q0, sorry. Q0, del is mentioned. Correct name. del Q0 and F. Okay, so Q, how many states here? So we can write down the states like this: Q0, Q4, then Q1, Q7, or you can relabel them. You can relabel these states, no issue. And Q3, Q5, Q6. Inputs are 0 and 1. This del is already provided here. Q0 is Q0, Q4. This is the initial state. Final state is Q2. Okay, and final state is Q2. Understood? Any doubt, students, within this?
No doubt.
Everyone understood? So how to find out the equivalency? Can anyone tell me? Okay, everyone able to view this slide? Next slide. New example is provided. Within that, a diagram is given, transition diagram. And for this transition diagram, we have to prepare the minimum state automaton. So try to convert it into a tabular format. That it is a transition diagram. We have to prepare the transition table. Prepare the transition table and tell me the transitions of Q3 state. What is the transition of Q3 for for A and B? Students, please reply fast. We have to prepare the minimum state automata here. If you have not understood, then please tell me. Don't reply fast. Transition for Q3, you can tell me just by observing the diagram. Not much difficult. So please reply fast. You can write down in the chat box, no problem.
So no transition for input A and Q0 for input B.
For Q3,
Yes.
no transition for input A.
A.
Self loop is there. You can observe this one.
Oh, yes. Yes.
Okay. So we can write down like this Q3 with input A, with input B. This is a final state, it is on itself, and for B, it is on Q0. So in this way, we are going to obtain the table. So from this table, just tell me the list of final state and non-final state. That is a pi 0. Pi 0. Can anyone tell me the pi 0? Set of final and non-final states. Please reply fast. You can write down with the chat box. No problem. Students, please reply fast. If you are going to reply, then we are able to understand that this technique is easy to understand to you or not. So how many final states here? Number of final states? Hello? Number of final states?
So 1, Q3.
Yes, and remaining are non-final states. Okay. So in this way, we are going to obtain the pi 0. That is Q3 is the final state and remaining all are the non-final states. So in the pi 1, we have to prepare the equivalent state, that Q0 is equivalent with how many states. So just check the equivalence and tell me that Q0 is equivalent with how many states. Q0 is equivalent with how many states. Just tell me that fast. Okay, thank you, Pujan. Correct set, that is a pi 0. It's a pi 0 divided by number 152. So prepare the pi 1 fast. 1 is equivalent with, sorry, Q0 is equivalent with Q0 is equivalent with 156. So remaining states are, that is 2, 4, and 7. So just check for the 2, 4, 7 and just try to write down the complete set. I want the complete set, pi 1. Can anyone please write down that pi 1 completely? Roll number 158, just try to write down the pi 1. Or other students can also please reply. Just write down first Q0 here. Q0 is equivalent with Q1, Q5, and Q6. That is correct. Now remaining states are Q2, Q4, and Q7. So Q2 is equivalent with Q4 or Q7 or with the both. Just tell me that first. Q2 is equivalent with Q4 or Q7 or with the both. You can reply within the chat box, no problem. If you have not understood anything, then please ask me. Okay, let's check the Q2 equivalence. Okay, so I just write down it here. So Q2 is equivalent with Q4 or not. So what is the transitions with us for Q2 and Q4? So let's see here. 3 and 1. 3 and 1. For 4, 3 and 5. 3 and 5. So if you observe Q3, Q3 within the one set, Q1, Q5, Q1, Q5 within the one set, so obviously they are equivalent. Q2 and Q4 are equivalent, no problem. Now we have to check Q2 and Q4 are equivalent. Q2 and Q7 are equivalent or not. Q2 and Q7 are equivalent or not. That we have to check. So Q3, Q1. What is the transition of Q7? Q6 and Q3. Q6 and Q3. So Q3, Q6, Q3 is here and Q6 is here. So they are not equivalent. So Q2 is not equivalent with the Q7. So within the pi 1, I'm going to obtain Q3. Then Q0 is equivalent with 1. Okay, I just write down it. So Q2 is equivalent with Q4 only, correct? Yes. I think 158, just revise your sets. Q1, Q5 and Q6. These are equivalent with Q0. So Q0 must be with Q1, Q5 and Q6. Okay. 152, that is correct. The set is correct. That is pi 1. In this way we have to prepare. Q0 is equivalent with Q1, Q5 and Q6. Then we have find out that Q2 is equivalent with Q4. Then Q7 is remaining. So we have to prepare a separate set for that. Okay. Now we have to prepare the pi 2. And when we have to prepare the pi 2, we have to prepare the pi 2 now. And when we are preparing the pi 2, we have to observe the pi 1. When we are preparing pi 1, then we have to observe the pi 0. So pi 1 is over. Now we have to prepare the pi 2. So when we are preparing pi 2, just observe the sets included within the pi 1. Clear? So now let's check again that Q0 is equivalent with Q1, Q5 or Q6. Clear? Reply fast, students. The state with set with the single element. So that is as it is, as I have written over here. Pi2 is consisting of the same, that is 3 and 4, sorry, 3 and 7, Q3 and Q7. Remaining we have to check again. I already displayed. So please reply fast. Any one of you? Q0 is still equivalent with Q1, Q5 or Q6 or not. That we have to check. Q0 is equivalent with Q1, Q5 and Q6 or not. So let's see. A, B. So is the transition of Q0, Q1, Q0, Q1, Q0, Q2, Q5, Q6, Q4. It is Q6, Q5, Q6. Okay. So when we have to obtain the pi 2, we have to observe into the pi 1. So let's see Q0 and Q1 within the one set. Yes, within the one set. Q0, Q2. Q0 is here, Q2 is here. So they are not equivalent. Means Q0 is not equivalent with the Q1 now. It is equivalent within the pi 1, but in pi 2 it is not equivalent. Now Q0 is equivalent with Q5. So 1 and 6. 1 and 6 within one set. 0 and here it is what? Q5, Q4 is here. 0 and 4. 0 is here, 4 is here. So they are not equivalent. They are not equivalent. 1 and then Q0 and 6 we have to check. That is 1 and 5. Q0 and 0 is here, 5 is here. Q0, sorry, Q1. Q1 is here, Q5 is here. Q0 and Q6. Q0 and Q6 is also within the one set. So they are equivalent. So Q0 and Q6 are equivalent. Remaining are Q1 and 5. So 1 and 5 we have to check. Understand? Yes or
Yes,
no?
sir.
Good. So 1 and 5 we will check. And then we are going to write on the set. So Q0 is equivalent with the what? Q6. Now this 1 and 5 is remaining from this set. So we are going to check their equivalence. That 1 is equivalent with 5 or not. That this 1 is equivalent with 5 or not. So A, B. So Q1, that is Q0 and Q2. Q0 and Q2. 5, Q6. So this Q0 and Q6. Q0 and Q6 within one set. Q2 and Q4. Q2 and Q4 within one set. So obviously they are equivalent. So here one set, another set we have prepared. Q1 and Q5 are equivalent. Q3 as it is. For pi 2, we are preparing the set for the pi 2. Q3 as it is. This Q0, Q6, Q1, Q5. This set is splitted into 2. Now you have to check Q2 and Q4. Q2 and Q4 still equivalent? Yes or no?
Yes, sir.
2 and 4. So is there any need to check? Q2
No.
and Q4. And lastly Q7. So if we are going to prepare the pi 3 and if we are going to obtain the same set, then we have to stop. And what we have to write down? That pi 3 is equivalent with the pi 2. Pi 3 is equivalent with the pi 2. But before that, we have to prepare that. We cannot directly write down that. We have to prepare it. So when I prepare that, I obtain that pi 2 and pi 3 are same. Pi 3 and pi 2 are same here. If you observe Q3, Q3, Q0, Q6, and Q1, Q5, Q2, Q4, and Q7. So as they are equivalent, we have to stop here, means we have to found up to only pi 3. No need to proceed for the pi 4. Yes? As we are going to stop here, we have to find out the transition for these new states. How many states? State number 1, 2, 3, 4, 5. Means I have just counted their states now. 5 states. And how many states we have here? 7. So obviously 5 is less than 7. So we have minimized this finite automata. So we have to prepare the transition table for that. So are you able to prepare the transition table? Everyone?
Yes, sir.
Prepare कर सकते हो? Okay. So we are going to stop the session here now. If you have any doubt, please post the message within the chat box. Just try to solve the another example. Just found the example. You can just search on the net, that is minimization of finite automata or examples on minimization of finite automata. Just try to solve that examples. Okay. Or I'll just give you more examples in the next session. So any doubts, students? Because we have to close the session now. If you have any doubt, then please tell me.
Yes, sir.